All right, so for this deep dive, we're taking on the sun.
Our very own star.
But this time we're kind of like, we're zooming out, right? We're looking at its place in the Milky Way galaxy.
Big picture stuff.
Exactly, the big picture, and we've got a ton of astrophysics papers, articles, all sorts of stuff.
Whole stack.
Yeah, and we're going to try to make sense of it all and figure out basically where our sun is, what it's like, all the vital stats.
Its cosmic address.
Exactly, and how it all fits into our galaxy.
It's easy to think of the sun as the center of everything.
Well, yeah, I mean,
from our perspective.
it is.
But on a galactic scale, it's just one of hundreds of billions of stars.
Oh, yeah.
In this huge barred spiral galaxy, over 100,000 light years across.
So where is it then? If the Milky Way is this giant spiral...
Where's our sun?
Yeah, where's our little neighborhood?
So we're located on the inner edge of one of the galaxy's minor spiral arms. It's got a bunch of names. You might see it called the Orion Arm or the local spur, but they're all talking about the same structure.
Orion Arm, I like that.
Yeah.
So we're on the Orion Arm.
Yeah, think of it as like a smaller arm nestled between the larger Perseus and Scutum Centaurus arms.
Oh, so we're not downtown Milky Way?
No, not at all.
We're like in the suburbs?
Yeah, we're way out, about 25,000 to 27,000 light years from the galactic center.
Okay, so that's pretty far.
Yeah. And this Orion Arm that we're on is estimated to be about 3,500 light years wide and potentially over 20,000 light years long.
That's still huge. I mean...
It is.
And the galaxy itself, like if you picture it, it's not flat, right?
No, it's got this...
So where are we, like, vertically?
Yeah, so right now, the sun's about 55 light years above the main galactic plane, kind of like...
Above or below?
Well, it depends on your perspective. But,
okay, I guess so.
And it does this really cool up and down oscillation going through the plane about every 60 million years.
So it's like bobbing up and down.
Exactly.
Wow. Okay, so we've got our address. We're in the suburbs.
Wow.
We're bobbing up and down.
Uh-huh.
What's the sun actually like? Like, give me the vital stats.
Okay, so first off, mass.
Okay.
The sun weighs in at about 1.989 times 10 to the 30th kilograms.
Okay, put that in perspective for me.
So that's like 333,000 times the mass of the Earth.
Wow, that's a lot.
And it actually makes up like 99.86% of the entire mass of our solar system.
Wow, so it really is the big dog.
Yeah, it's the gravitational powerhouse holding everything together.
Okay, all right, so massive. How about size?
Diameter's about 1.4 million kilometers.
So like a million Earth could fit inside?
Yeah, a little over a million.
Wow, that's crazy.
And for something that big, it's incredibly round, like only a 10-kilometer difference between its poles and equator.
Huh, pretty spherical.
Yeah.
And it's hot, right? Like really hot.
Oh, yeah. The surface temperature is about 500 to 5,800 degrees Celsius.
1,000. That's, I mean, we can't even imagine.
No, but then the core, where all the nuclear fusion's happening, that's about 15 million degrees Celsius.
15 million? That's wild.
And here's the weird part. The outer atmosphere, the corona, that gets super hot too, up to 3.5 million degrees Celsius.
So it gets hotter further away.
It does. It's a bit of a mystery how it gets so hot out there.
Science, huh?
Yeah.
All right, so how old is this thing? Where does it fit on the timeline?
It formed about 4.5 to 4.6 billion years ago from a cloud of gas and dust, what we call a solar nebula.
So it's just like floating around in space.
Yeah, and something triggered it to collapse and start forming the sun.
What was the trigger?
We think it might have been shock waves from nearby exploding stars, supernovae.
So another star died and gave birth to our sun.
Yeah, it's like a cosmic recycling program.
Wow. Okay, and how long does it have left?
Well, it's about halfway through its lifespan. It's got another 5 billion years or so.
So middle-aged.
Yeah, you could say that.
And it's not just sitting there, is it? It's moving.
Oh, yeah, it's on a big journey around the galactic center.
So it's orbiting.
Yeah, it's in a broadly elliptical orbit with those up and down motions we talked about.
Like a cosmic roller coaster.
Kind of, yeah.
And that orbit's tilted too, right?
It is, about 60 degrees relative to the main plane of the galaxy.
How long does it take to make one orbit?
We call that a galactic year, and it's somewhere between 220 and 250 million Earth years.
250 million years. Wow, so it's made about, what, like 20 trips around?
Yeah, somewhere around 18 to 20.
And how fast is it going?
It's cruising along at about 220 to 251 kilometers per second.
That's incredibly fast.
It is.
So what's this thing made of?
Mostly hydrogen, about 75% of its mass.
Okay.
And then helium, That makes up around 27%.
Okay, so most of it's just hydrogen and helium.
Yeah, and the remaining 2%, that's all the heavier elements, things like oxygen, carbon, neon, iron.
It's like all the stuff that makes up planets.
Exactly. And because it has these heavier elements, we classify it as population I star.
Population I.
Yeah, that just means it's relatively rich in these heavier elements, what astronomers sometimes call metals.
So a metal-rich star. Interesting.
And this composition changes over time.
Oh, yeah, how so?
Well, in the core, where the fusion's happening, the hydrogen's being converted to helium, so there's more helium now, about 60%.
So it's changing from the inside out.
Yeah, and the heavier elements, they tend to sink towards the center, too.
So the core is getting denser and denser.
Yeah, but the surface, that still reflects what the solar system was like when it first formed.
Okay, so this giant ball of mostly hydrogen and helium with a sprinkle of other stuff, it has a big impact on us, right?
Huge. I mean, gravity holds the entire solar system together. All the planets, asteroids, comets, everything.
Okay, so we'd be lost without it.
Literally lost, floating off into space.
And it gives us energy too, right?
Absolutely. All the energy we get from the sun, that's coming from nuclear fusion in its core.
How much energy are we talking about?
It's putting out about 3.8 times 10 to the 26th watts.
That's a lot of zeros.
It is. And that energy that drives everything on Earth, our weather, the climate, the water cycle, even photosynthesis, it all comes from the sun.
So life itself depends on the sun.
Yeah, it's pretty fundamental.
And of course, it can't last forever, right? Everything has a lifespan, so what's the forecast for our sun?
Well, in about 5 billion years, it's going to run out of hydrogen fuel in its core.
And then what?
Then it'll enter what we call the red giant phase.
Okay.
The core will contract, but the outer layers will expand massively, probably engulfing Mercury and Venus, maybe even Earth.
So bad news for us.
Well, yeah, in 5 billion years.
Yeah, that's a ways off.
And it'll get much brighter, too, like 2,000 times brighter than it is now.
Wow, a real giant then.
Yeah, and it'll stay like that for about 1 billion years, losing a lot of its mass in the process.
And then what happens?
After the red giant phase, the outer layers will drift off into space, forming what we call a planetary nebula, and the core will collapse into a white dwarf.
A white dwarf.
Yeah, it's a super dense, hot object about the size of Earth.
So our sun will shrink to the size of Earth.
Essentially, yeah.
That's mind-blowing.
And it'll just slowly cool down over billions and billions of years.
Until it just fades away.
Yeah, eventually becoming what we call a black dwarf, although we've never actually observed one because the universe isn't old enough yet.
So it's like the final stage of a star's life.
Yeah, for a star like our sun anyway.
Okay, so no supernova, no black hole.
No, it doesn't have enough mass for that.
All right, so in the grand scheme of the Milky Way, with all these billions of stars, is our sun special?
It's a good question.
I mean, it's special to us, obviously.
Right, it's our sun.
But is it unique?
In some ways, it's pretty average, like its size. It's right in the middle of the pack.
Okay.
But it is more massive than about 95% of the stars in our neighborhood.
Oh, so it's bigger than most.
Yeah. And its surface temperature, that's pretty typical for its type, a G-type main sequence star.
Okay.
It looks bright to us because it's close,
Okay.
but in terms of its actual brightness,
Yeah.
we call absolute magnitude, it's brighter than about 85% of the stars in the galaxy.
Okay, so not the brightest, but still up there.
Yeah, but what's really interesting is its stability.
Stability.
Yeah, its energy output, it varies very little over time.
Why is that important?
Well, for life to evolve on a planet, it needs a stable energy source.
Oh, I see. So our sun's stability is what allowed life to flourish on Earth.
Exactly. And there's another thing. Our sun is a single star.
Meaning?
It's not part of a binary system, which is actually more common than single stars.
So most stars have a companion.
Yeah, they orbit each other.
But our sun is a loner.
Pretty much, yeah.
And of course, it has a planet with life, which we haven't found anywhere else yet.
That's right. That's pretty special.
So it might seem ordinary, but our deep dive has shown that the sun's combination of properties, especially its stability, makes it pretty unique in our experience.
It does make you wonder how many other single, stable, metal-rich stars are out there.
And how many of them might have planets with life?
Yeah, it's a big
The
question.
question for another deep dive.
Absolutely.
Thanks for joining me on this journey to explore our extraordinary star.
My pleasure.
It's amazing what we can learn just by looking up.
It really is.
Until next time.
See you then.